Good morning, everyone, and welcome to our Pondside Talk from Wet Plan. Just a few housekeeping rules as we get started. You've entered in mute mode. Please stay muted with your cameras off to save bandwidth. And we'd like to ask you to use the chat feature to write your email address if you haven't already given it to us. Some of you may have already done that. And your zip code. We just use this information to keep track of attendance and how far we're reaching in the county. And this information will not be shared or made public. You can ask questions through the chat feature, and please be aware that we are recording this session. If you have a question, make sure you unmute yourself so we can hear you, and please be brief. So thank you for joining us today. I am your moderator, Karen Miller with GHD, and our other wet plan partners are also on the phone. Marlene Rodak with the Coco Lobo chapter of the Florida Native Plant Society. We have Maria Romero, the TMDL coordinator for Lee County Division of Natural Resources. Ernesto Lasso de la Vega with Pond Watch is here, and also Lee County Hyacinth Control District. And Andy Tilton with Johnson Engineering is also on the phone. Today's speaker is Dr. Serge Thomas. We're really excited to have him here from FGCU, and he's going to talk to us about the do's and don'ts of urban man-made ponds in Southwest Florida. And here you can read Dr. Thomas's bio. He is associate professor from the Department of Ecological and Environmental Studies at Florida Gulf Coast University under the Water School. He's an expert in algae and in nutrients and nutrient loadings, and we're very excited to have him here today. So right now I'm gonna stop sharing and I will let Dr. Thomas take over.
Good morning, everyone. Everybody sees my screen?
Yes, we can see it.
All right, terrific. Okay, so what I'm going to talk about is, what you're supposed to do and what you're not supposed to do in urban-made ponds. So I'm going to give you a little overview of what I'm going to be presenting. So I'm going to first talk about stormwater treatment areas, which are similar to, not similar, but basically could be used as an example of what those ponds are supposed to be, meaning they're supposed to clean water, and could be very well be like wetlands to clean water. So I'm going to talk, digress a little bit to talk about the regulated agriculture area and those STAs are found there. And then I'm going to give you a short overview of what those ponds are used for and how they actually are not being used as. And you'll see that we have a lot of problem with algae, especially growing everywhere, such as toxic algae sometimes. And we also have a problem with bank erosion because of the lack of vegetation surrounding the pond. So I'll mention a bit about this as well. And then we're going to be looking at an expected effect on ponds. Apparently, ponds are normally mandated to clean the water, but also to recharge the aquifer. And apparently, they do not fulfill that second requirement. And then how we can actually fix ponds in a bad way. So don't chemical mainly are used, and using eventually dye or using some type of mixing to mix the water. And I'll show you why it's efficient. And dredging, which is sometimes last resort to be done, as well as using phytoremediation, so using plants to help you to get rid of the nutrients and algae, as well as mention briefly about hydrogen peroxide and bacteria and enzyme, which is kind of new, and there is some research done here at the water school as well, which I will not present that. That will be somebody else maybe at some point. And then using also the pond as a way to elevate ourselves and keep people informed, and especially kids, about water quality in Florida. So I'm doing some environmental education and what I'm doing right now, and also as future research. So again, I'd like to mention that we're all part of a larger system, And the system in Florida is especially all about getting the water right. So meaning that the water timing in time and the water quality must be perfectly timed as well. So here we have a display showing you Lake Okeechobee, which, as we know, used to actually deliver water to the Everglades through the river grass down here. However, you can see that the system has been heavily impounded and impacted by having what I call a blockage between us and Florida Bay with the Everglade agriculture area, which is here, and the water now is being diverted east and west, west and east here, to the coast, and those connections never happen. So that's definitely not getting the water right, right? And the water quality is also not good because the water that exist, especially those Everglades agriculture area, is very heavily loaded with nutrients, and especially phosphorus. So phosphate is the enemy of inland freshwater quality, and the Everglades cannot have more than 10 parts per billion, so that's not much nutrients. If you're looking at the whole world population, we say we have 7 billion people. So let's say 70 of those 7 billion people, and you basically have the criterion for the Everglades good water quality, which is 10 parts per billion. So not much water, not much phosphorus. However, the agriculture area has phosphorus in sometime in the 140 to 250 parts per billion, right? And that will impact the Everglades. So what we do is that we put some impoundment there, which are STAs, so stormwater treatment areas. So what are those STAs? So those STAs are basically shallow impoundments where the water will go through, and they will clean the water using plants and algae to polish the water in the end. And the water that will be released from this pond will be clean and safe to be released into water conservation area first, and then eventually to the Everglades. So how does that work? So again, you're having a high inflow of phosphorus getting into your pond, into your wetland, and then you have eventually some plants, especially typha, so the cattails, and then some submerged aquatic vegetation that will continue to polish the water until the water has decreased from actually 140, 200 parts per billion to 25, 50 parts per billion. And after that, we're having the algae polishing the water until the water is nearly like the water you have in the Everglades. Not exactly, because the concentration is 30 to 15, and in the Everglades really requires less than 10 parts per billion. So we're still a bit high, but that's still very, very good water quality. If you're looking at the entire United States, the criterion for phosphorus before being impaired for the water quality would be 50 parts per billion. So in the Everglades, in our region, 10 parts per billion is really the standard. And for some of those ponds, because that's my transition to pond, they should be around that vicinity. 30, 15 would be a good number. Unfortunately, most often they are more than that. So we'll talk about that. So the other thing I like to mention is that we're all part of the system and we're all part of the problem. So if you move to Florida, that's Lieutenant Colonel Reynolds, who is now retired from the Army Corps of Engineer, who said at the Water Summit, Several Water Summit in August 2019, that we're all part of the problem, and that if you've food that you haven't grown yourself, you're part of the problem. If you use a bathroom and flush a toilet, you're part of the problem, etc., etc. So the idea is we're all part of the problem, and what can we do on our end to fix it, right? It's not only the sugar farm, it's also us. So that's my transition here to pond, because you got to remember those ponds are normally ecological filters. They're supposed to clean the water, so the water is safe to be released into the natural systems, as well as moderating the flow of water over time. So getting the water timing and the water quality right? So we're the same adage here. So pre-urbanization, you pretty much had a land with a lot of vegetation growing. And when it rains, eventually the vegetation will absorb some of the rain, so limit flooding, as well as allow to recharge the aquifer and filter for nutrient and other debris that you might have in the surface runoff, such as silt and clay, for example, which can choke estuaries. And after urbanization, obviously, you have a lot of what we call impervious, so impermeable surfaces, and the water now create very quick sheet flows that will basically, flush off the street and flush all the nutrients as well as metals and other undesirable pollutants. And those nutrients will quickly get into the natural system. Now, what we did is that since 1982, we implemented retention or detention ponds. So these are artificial man-made ponds. We don't really have many ponds in Florida that are in Southwest Florida that are natural. So most of the ponds you see are man-made. And those ponds are supposed to clean the water so that 80% of the water is clean when it leaves the pond. So when you have an outflow, supposed to recharge the aquifer and remove the nutrient from the water, as well as they're being used as a decantation pit, so that the silt, the sand, etc., will settle down to the bottom of the pond, so the water that exits the pond is clean of all those pollutants. So here's a lot of wording here, but basically this is what they're mandated to summarize. So one is to pass out the water right. So during the dry season, if there is a rain, they will keep the water into inland, because our water is not supposed to go down to the estuary during the dry season, because we do have rain during the dry season. And then during the rainy season, when it rains a lot, then it will overflow through the overflow box and release the water, which has been cleaned. Up to 80% of the nutrients and the other pollutant will be removed by using those ponds. So most of those ponds are like the aquarium filter, right, to clean the water as well. So I'll pass this. This is just if you want to know more about what the different criteria are for cleaning the water. Now you have different type of pond. You have the dry pond versus the wet pond. So the wet pond are definitely the ones that are wet all the time and generally dug through the at least below the water table. And the dry pond are built above the water table. If I really had a choice, I would prefer to have dry pond, which are basically wetlands, because wetlands do a wonderful job cleaning the water. However, people want to have a lake, right? Not a pond, a lake. So this is a lake, the wet pond that we have, right? So they're again dug below the groundwater table, so they're flooded all the time. So the way they function is normally you should have, if you have a good pond, a good surface area covered by aquatic vegetation. So ideally 35% plant cover is the ideal. So this is your plant in the littoral zone, so the shallow zone of the pond. And then you'll grow eventually some algae, right? The algae are okay, but they're not very good to sequester nutrients in the way that they can be exported. An alga is generally not attached and eventually can migrate through the overflow box. So not a very good way. So the best way to sequester nutrient is really on the shoreline in the littoral zone. And anything also above the shoreline also will help. And they will also, again, help the sedimentation of heavier stuff, right? Stuff that will sediment to the bottom. So they're supposed to fill out over time. It's part of the natural cycle. When I first started to work on ponds here, I used to work on pond on the East Coast, and I have been at FGCU since 2008. Nobody had any idea of how many there were or what surface areas they encompassed. So we started a project with students, and we just used Google Earth, and we tagged those ponds, and we found that they were about, between Lee and Collier County, about 10,000 of those ponds, and now we're more into the 12,000 of ponds. When you put them together, so that's so we also look at when the ponds were dug, not all of them, just a subset, and we extrapolated. And you can see that basically they mimic the population growth in Florida, especially in Southwest Florida here where we are. And remember, Lehigh Acre, Coral, Cape Coral, and Fort Myers are very often in the top 10 fastest growing cities in the entire United States. Right, so the pond just mimics the population demographic here. If we're looking at the size, most of them are small, so that's a number of ponds here and their size, although you do have some ponds that are over 10 acres. If you combine all those ponds together, we actually have a volume in the surface area very similar to 1.5 times the surface area and volume of the Caloosahatchee River. right? So it's substantial when you combine them all together. So obviously, if they are in bad water condition, you probably will not have good water coming out of those ponds. And we mentioned very often the Caloosahatchee River, but we very often overlook the pond water quality. So that would be my ideal of a good pond. Basically, it's got a lot of vegetation on the flood zone, so the zone that actually is above the call it the wet zone, above the where the water is permanently there. You do have a good overflow box, so the water will be protected. You have a lot of filtration, all right? So most of the plants and algae and will filter the water so that the water that hits the water really has low nutrient concentration because you don't want to grow algae, right? Especially bad algae. But if you do, the algae will uptake the nutrient, right? Eventually they'll sediment to the bottom and also they'll feed the food chain. And of course, you want to have a good top-heavy food chain with a good population of fish eating fish, right? Now, when you actually have good water quality, there is a little conundrum here with Florida because we're growing basically systems that look like the Everglades. And if you've never been in the Everglades, I'd like to show you a few pictures of what they are. This is actually a picture of the Everglades full of algae. And those algae actually are healthy, good algae. It's called periphyton. So peri means around and phyton means alga or plants. So they're growing around the plants. And you can see those actually, we call them sweaters. They basically are trying to get the nutrient out of the plant because there is not enough nutrient in the water. So in Florida, naturally, if you see a system like this is a system that is actually healthy, super, super healthy with very, very, very low nutrient. And I know it's really weird because when we think about algae, we think about problem with nutrient. However, in Florida, with low nutrient, you actually grow what we call the good periphyton, the good algae here. And they're very important in the way that they clean the water, they prevent phosphorus buildup in the water. They also create limestone. So they actually will sequester the phosphorus in the limestone, the calcium carbonate, and then you'll actually will have a good sequestration of your phosphorus in your water. And when they decay, they don't really stink. They actually help a lot. So with a smell. So they also have the base of the food chain, they oxygenate the water. So you have a lot of different things here that are good water quality here for the periphyton. So the periphyton is number one, and there is good, bad, and the ugly, and that would be another lecture here, another presentation. Sorry, that's a professor teaching here. All right, so most often those ponds, that I showed you pretty much what a pond should look like. And sometimes it's growing these algae which people don't really like, but the reason I'm doing those workshop is that I want to spread the word that if you see the good periphyton, you should be thrilled. You should be really happy to see those periphyton because this is actually the good healthy water. And there's a way to mitigate the look, right? By planting, generally you will have those algae more into the shoreline and not into the open. So that would be more acceptable for some, even though, if you've been living here in Florida and you've been in the Everglades all the time, people know that's the way the system is supposed to look like. Okay, so it's just about perception sometimes and education. So most of the time, people don't want to see those algae, and they also don't want to see the plants because they want to see the open lake view. So no plants, no algae. The problem is that, remember, those ponds are supposed to sequester nutrients. So this is, if you have open water, it's not a good way to sequester nutrient. You will start to grow not the good algae, but the bad algae. Because the algae in the Everglades, like good water quality, if the water quality shift to nutrient-rich water, then you'll grow bad algae and eventually toxic algae. All right. So the other thing is, ponds are being designed so that they could accommodate most people having a lakefront view. And we'll see it later, the lakefront view has a implication regarding your real estate value. So this is what we have here. This is Longshore Lake to the left. And then we have, I think it's Village Walk or Island Walk. I mean, it's probably from the same architect, where you basically have a lot of people, so that everybody has a view to the lake, right? So your real estate value increases. And as of 2019, they're still building the same concept development here, right? So people want to have this, a glacier lake appearance, which what most people who come down here are accustomed to, because that's what they have over there in Ohio, Wisconsin, or higher states in a higher latitude. However, in Florida, I showed you what the system is supposed to look like. So they will do everything possible to have the system look like what they're accustomed to. They're basically modifying the ecology of the system so it'll suit their needs. However, it will not suit our water quality. So we did a little survey here with looking at houses with a front view property, houses with no front view property. That's about a gain of 9% in average for comparable houses in the same neighborhood, right? So there's a little gain here. You're buying the house, you're also buying the view. The other thing is that people wants to bring in Florida are lawns. Well, we don't have lawns naturally in Florida. We have different type of grasses, but we don't really have lawns as sod as we see. So, but that's what they have up north. So they want to see this down here as well. And we also have the golf courses. We'll talk about those as well. Those are necessary, right? If you like golf, you need to have lawns and turf. So the problem with those lawns is that they require a lot of nutrient, a lot of watering, especially during the dry season, and a lot of pest control for either insects or weeds, right? So all of those will not be very good for your water quality, especially if you have no plants growing between your lawn and the edge of the water. The other issue is reclaimed water. So reclaimed water is a daunt here, especially when the reclaimed water is leaking into the pond. It's actually a picture from Longshore Lake where sometimes the sprinkler is destroyed, and then you have the water directly getting into the pond. This is very high phosphorus concentration. There is, by the way, no required target for phosphorus in the reclaimed water in Florida. There is some for the nitrogen, but nothing for phosphorus. And again, phosphorus is a problem here in Florida, especially. Okay, so that water gets there, and you also have some pond. Actually, I'm studying one that receive directly water from the reclaimed water, because the idea, hey, those ponds are supposed to clean water, so why don't we send the reclaimed water from the wastewater treatment plant to those ponds, and the pond will cleaning up. It would if you had plants. However, it does not do it very well. It grows algae if you don't have plants on the littoral zone. So what people do, well, different ways. If you have good algae, they don't want to see the good algae, they kill it. If you have bad algae, they will kill the bad algae, they kill it. Now remember, if you don't have plants or algae, nutrients are not being sequestered. Okay, so that means that the nutrient will escape at some point into the natural system, and then we have algae bloom into the bay. We are connected in the system totally here. This is an example of a pond with no vegetation. If we had vegetation here, like a good stand of cattail, that would capture those nutrients. However, we don't have anything, so the runoff comes down here. There is nothing to block it. The grass also is overfed with nutrient and eventually reclaimed water, and then you're growing bad algae. These are green, not like the whitish brown that you saw a little bit earlier. Those really stink when they decay. They sediment to the bottom and plug your pond and create very bad odors when they decay. Nothing to do with the good periphyton, the good algae. All right, these are another example of bad algae, very greenish. So you're growing mainly green filamentous algae and sometimes cyanobacteria, which can be very toxic. This is actually not a cyanobacteria, it's actually a Spirogyra, a green alga. So these ponds, again, are supposed to remove nutrients and pollutants. If we're looking at what they're supposed to do compared to what they're mandated for, so in AMEC, in 2011, I paired with AMEC, which is a consulting company, and we looked at their nutrient retention. As you can see, when you see a negative number, it means that they become a source of nutrient pollution and not a sequestration of nutrients. So you can see sometimes phosphorus, you're actually producing nutrient, and also with generating TSS stands for solid, suspended solid, so silt, and copper. Copper is actually one of the algaecide being used to control the algae, because if you don't have plants on the shoreline and you have nutrient coming into the pond, you will grow algae. Now people don't want to see the algae, so you use copper sulfate or chelated copper to kill the algae, and then the copper will be found in the water be released from the sediment eventually to the water and get into the bay. And that has, we're still documenting this. I have actually a project right now looking at the copper effect on oysters, especially, and seagrasses. You know, if you're losing your oyster, you're losing a big filter, right, in the bay, because oyster filter a lot of water. And same for the seagrasses, they do consolidate the bottom and remove nutrients from the bottom, from the water. So just an example here of some of the pond I studied. So I studied overall about 250 ponds since I got here in Florida, in Southwest Florida. And so this is actually Pelican Landing. And we surveyed 11 of those ponds at a very high frequency, so once a month. And these are the ponds that we studied. And basically, we also looked at, at their relation between their land use around and the pond. And most of the ponds that have issues, I'm going to summarize this graph here, are mostly from golf courses, as well as surrounded by home. The ones that are surrounded by natural land actually did much better in terms of eutrophication, nutrient concentration, compared to the ones that don't, not surrounded by natural lands. The other thing that we found is that there is a plethora of algicides and herbicides that are being used to basically control the plants and the algae. And just to show you the arsenal of some of it, of what they use. So we have a lot of copper base. We also have glyphosate, which is basically Roundup. And they use also sonar post. Some people do raking. That's good stuff. Raking is better than using those methods. But imidazapyr and diquat, are very common, and hydrothol, very common to control plants and algae. But what's important here is that in that graph, because I'm going to summarize this again. So this is just a stack to show you pretty much how they use those xenobiotics, those herbicide, algicide. What you can see is that the algal concentration is very erratic, and that's a algal concentration right here. It's very erratic, and it does not follow the treatment. The treatment really do not really control the algae anymore, because the algae start to actually be resistant to those algicide and that you use to control them. So you're generating basically monster that will basically not be controlled easily. All right, so this is also show you some of the community I've surveyed. This is coming from an old slide from 2015, so the list is much longer now. But you can see that most of the ponds are what we say nutrient super rich, right? Nutrient rich, nutrient super rich as well. This will be hyper rich, nutrient rich and rich. And not many of them actually are good water quality. Actually, none of them are good water quality like you would find in the Everglades. Maybe this one here, which is actually in Carlton Lake. Carlton Lake has generally good water quality. But you can see that they have issues, right? They all have issues pretty much. Now, what we have as consequences of being misused, you're going to have muck accumulation on the bottom, right? You're going to have phosphorus accumulation on the bottom. You're going to have copper accumulation on the bottom, especially in zones where they apply the copper. This is an easement here, so you can see where you're applying the copper. The copper shows up in their sediment. And eventually that copper will wash into the bay. This is Naples Bay. And you have a huge culvert here, and that shows a dry season, wet season, but you have a hotspot here of copper. And the EPA for copper is 3.7 part per billion. After that, it's been impaired. And you can see that value are more than that. And in some pond, I measured up to 2,400 part per billion of copper that being actually released into the bay. All right. So currently we have a project with Rachel Pinnell. So Rachel Pinnell is a master student, and I'm co-mentoring her. And she's looking at the effect on copper accumulation in oysters. And we do find a lot of copper in those oysters. And the oyster is only the tip of the iceberg. The baby of the oysters, which are zooplankton, are much more susceptible to the copper sulfate than actually the older adults. And that could actually impede the recruitment of new oysters in Naples Bay. Now, the other question is, do they recharge the aquifer? Well, apparently they do not do that very well. So this is Village Walk. So we know we have a good connection. So Village Walk actually uses groundwater. They actually have a well here, and they pump groundwater to maintain the water level steady in the pond. And when you're measuring the salt, because groundwater is saltier than the fresh water that you have in the pond, you can see, so that's basically number 2. This is the arm number 2, arm number 3, arm number 4, and arm number 5. And as you can see from arm number 1, which is right here, which where you number 2, sorry, where you're pumping the water, it's high in salts, and the salt after that migrates slowly into arm 5 until it gets fully dissolved. So there is good connection. Even though you see those fingers, you still have connection of groundwater that move around those fingers. So we have good water circulation underground because we are in a limestone, which is like cheese, and the water move in and out that cheese, which is a limestone. So we have underwater rivers under our feet in Florida. So what we did, we tried to assess that groundwater, and we used a groundwater seepage, which is basically a 55-gallon drum. We're cutting it in half, and we capture the groundwater that eventually would come here, and eventually will collect there into a bag. So when the bag inflates, we know we have groundwater going into the pond. When the bag deflates, we know we're losing groundwater, and we're measuring the groundwater nutrient using a groundwater well, all right, to know how much nutrient is coming into the pond as well with the water from the groundwater. So we've done this on campus at FGCU that got published, and basically what we found is that the water overall is mostly coming out of the groundwater to the pond, and only a few times does the pond recharge the groundwater. So first take here, the pond doesn't seem to actually recharge the groundwater. There is more evapotranspiration, more evaporation from the water from the pond that actually there is groundwater, water coming from the pond into the groundwater. So we're losing groundwater by having those ponds. And remember, they were mandated to groundwater recharge. We also did this in Naples. That's Little Harbor, and we still continue to work there. And as you can see here, same thing happened. It's mostly an export of groundwater into the pond rather than not very often, some actually pond water feeding into the groundwater. The other thing is that groundwater is very polluted and increases the nutrient concentration in the pond. So not only do we have problem with surface nutrient, we also have problem with groundwater, superficial groundwater aquifer being highly loaded in nutrients and feeding those algae as well. So I'll pass those, maybe a bit faster here. So how do we fix this? So, chemicals have probably not a good way to do it. That would be last resort. Unfortunately, chemicals are cheap and efficient. We can also dye the water. So dyeing is making the water blue so that the algae will not grow. Again, you're just masking the problem. You need to have the algae grow to sequester the nutrient because remember that pond is connected downstream to the ecosystem, right? So you don't want that nutrient exceeding the pond. Another one would be mixing. So mixing is those aerators, right? So what does the aerator do? They mix the water so that the water is well mixed and not what we say stratified. And that allows the algae to move up and down. And they hate that. They hate to move up and down like this because they create those convection cells. And we also are digesting the muck by providing some oxygen. And the oxygen will help the aerobic respiration of the muck. So basically transforming muck into carbon dioxide. Like the same thing you would do when you eat a burger. You're eating the burger, you're respiring oxygen to oxidize the burger, and then you're releasing carbon dioxide. So that's what the bacteria do when they're provided with oxygen, especially. And then we also lock the iron and the phosphate together. There is iron in the sediment, and when there is oxygen, the phosphorus locks into the iron. So you're blocking the phosphorus in the sediment as well. So so aerators are good. They're always useful, all right? And they're not all the same. That will be another lecture about aeration here. So I'd like to show you though that the aeration effect is very limited in space. So this is just a 1-acre pond with 2 aerators I mentioned here. And this is just to showing the temperature because they bring cool water from the bottom. So you can see it does not really affect the pond overall that much. And same for the oxygen. Doesn't really affect the entire pond. Now, for sure, there is some more work that we're doing currently, and we're doing some measurement of flow and see how the flow is being moved by those aerators in those ponds. Then there is dredging. Dredging is traumatic. It resets the pond to its original setting by removing the muck, but it can be very, 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 very expensive, right? Because the muck sometimes has chemicals such as copper, or sometimes arsenic, which is used sometimes as a pesticide, or naturally occurring arsenic that will basically make the dredging cost about twice the amount because sediment now is very, very bad quality, and it's toxic. Basically, you have to send it to a treating facility. This is an example of a lake that's been fixed. That's Lake Manor in city of Naples. So that's what Lake Manor looks like. And then they actually remove dredge and also created a park next to it and restored the bank. And this is what the water looks like now. However, for a 4-acre lake, it costs them $1 million to do that. So the idea is, don't mess up with your pond. It will cost you a lot more in the end. Phytoremediation, so using plants to clean water. So sometimes people don't want, not sometimes, most often they don't want to have plants on the littoral. So they will actually use phytoremediation using floating islands. So those floating wetlands are basically wetlands that are floating with plants, and the plant will remove the nutrient as well as release chemical in the water from the root to control algae, and also harbor beneficial bacteria to remove nutrients as well, and also provide some harbor for fishes, small fish as well. So that actually was published, and we also have a thesis out of it. This is Dana Detmar, who works now for the city of Sunnyvale. And then there's the hydrogen peroxide and the bacteria enzyme. So those are bacteria and enzyme. I still haven't found a good study to actually show that it's working. Yeah, apparently people say it's working. I still try to find a good person willing to eventually give us money to test it in the real life, not in aquaria, in a real pond. And then hydrogen peroxide. So Dr. Toshi Hirakawa, so Hirakawa is his last name, he's actually doing a lot of hydrogen peroxide work, and he's been very successful. He's been funded by FDEP, Florida Department of Environmental Protection, and he's got several papers. So it looks like it's really working well. I'll let him eventually present his finding to this group. And then there is a friendly landscaping, right? Planting. Everything that you will do to prevent the nutrient and the runoff that has nutrient to get into the open water is a bonus. So you want to stay away from lawns because they actually are sources of nutrient, and you want to do friendly landscaping using natural plants to basically sequester the nutrient before they actually reach the open water. All right, so Jerry, that's what you have. No littoral zone, lots of erosion. This is from Michelle Atkinson from the IFAS. She has got a lot of work on this littoral planting. So this is a good source. She's over in Tampa. So IFAS is UF, that's the University of Florida, right? More picture here. And she has all those very nice drawing about what type of plants you can plant depending on the elevation regarding the edge of the water. And this is what it looks like when it's planted. So you can have lawn, but still have that good buffer zone that basically will sequester the nutrient. So your water in the center is devoid of nutrient. This is really what you want. So it's like you're creating a stormwater treatment area, right? A water filtration from your pond, and also create habitat and wildlife attraction as well. So of course you want to plant at the right place. You want to select some plants that don't require any irrigation. So xeriscape is a big pro here. And then recycle eventually the plants that you have to remove, and fertilize, but be cautious here, and make sure you do best management practices. There are several organizations such as Greenscape Alliance actually teach you how to best manage your pond as well as wet plant, of course. Right, just show you a few pictures here of restoration. You want to leave a buffer zone, not mowed or treated. This is another example from, again, Michelle Atkinson, showing you how you can restore banks. And then there's another one, Senate Bill 82, which actually allows you since June 26th, to actually plant edible garden instead of having a yard. So at the same time you're planting edible, you're replacing the grass, and you also eating locally, which also help water quality on a much broader scale. Now, if you're doing the right thing, this is Carlton Lake. They started with moderate amount of nutrient, implemented a lot of good management practices, got rid of copper sulfate, did a lot of planting, a lot of rain garden, and this is a nutrient trend. And now they have a good problem. They're growing the good algae, right? The algae that grow in the Everglades. And now they're trying to actually mitigate that because some residents don't like the view of it. And this is really the conundrum, right? How do we make people accept very pristine like water, like the Everglade, and growing Everglade-like system in their backyard? I would be all found for that, but because I know what the system's supposed to look like, most people don't. So they think it's not good. So there's a lot of education that they're doing right now. And then we're using pond as well to teach about water quality. So we actually have a 319H grant from the EPA that's fueled through FDEP. And then we are actually using the pond. So most schools have a pond, backyard pond, to teach about water quality to those young, fresh mind from K through 12. And we teach them about water quality and have activity about water quality and planting as well, so they understand. And we're especially focusing on Title I schools, so the school in poor neighborhood, because if the water goes bad here, these will be the people who probably will be more likely to stay in the region, while the rich people will probably just vanish and leave, right? So we want to make sure that those kids know or tell their parents we should vote to the right person at the office. Water quality is very precious. We're all part of the system. All that kind of thing is something they learn. All right, so make sure that they also understand about wetland and flow and discharge. So this is the density reduction groundwater recharge, the DRGR, that has been very, very heavily impacted. So we teach them about that as well. And then, of future research now, I'm looking at bacteria enzyme treatment. Eventually, at some point, I have a few leads with a company in Cape Coral. I also do more algae experiment to see how we can prevent algae growth using hydrogen peroxide with Dr. Hirakawa. I'm also using drone now, to especially study water quality from the above. And we've used also satellite picture to assess the amount of vegetation. So SAV, EAV is submerged or emerged aquatic vegetation. And the student actually counted from what they could see from from the aerial picture, what is the current status on plants on the littoral. And this is what we found. So we don't have a lot of ponds that have a lot of plants, pretty much, right? And then you can see that some will actually have enough plants. It's not so many, right? So 30% is our target. 30% of planting on the littoral zone will be the best to cope with water quality. So there's a lot of work we have to do to have more planting in the littoral zone. I'm also using some special camera to assess the water quality from the sky. So it's a multispectral camera. And we found by using just the color in the camera that a lot of those ponds have bad water quality. Again, this is not calibrated yet. This is just a guess, but we could use eventually satellite picture to assess water quality from above. And then we also looking at the groundwater surface water interaction by using drones. So we're using infrared. This is an infrared camera. So this is our new drone we're getting in June. That's close to $250,000 drone. And then we have a very good LiDAR system to measure elevation and delineate watershed, as well as, again, looking at multispectral, the different type of color. And we're trying to see, if we have a lawn that's very lush, do we have bad water quality? So we should be able to do this currently, because we have actually a new grant, trying to find out if a lush lawn means also a lush green water quality. All right, and this is basically what we're doing right now in Bonita Bay Community Association. This is a really cool community here. I like to mention them. So they have terrible water quality. They've been here for a long time. They're receiving reclaimed water from directly feeding into the pond from the wastewater treatment plant in Bonita Spring. And then they have terrible water quality. So we're trying to find and to show that the water quality is bad because of the reclaimed water. And we're using sucralose, fake sugar, to trace that. We're also looking at the sediment accumulation in those ponds. Those are perfect because they've been unaltered for 40, 50 years. We're also looking at the land use and flood. So we're doing some flood modeling to see if the landscape is actually well designed. And we're also looking at the sources of nutrient using some what we call stable isotopes. So it's one way to trace a nutrient. Is it fertilizer? It's mostly reclaimed water. And then the most important, this is a community participatory research project where basically we have a lot of citizen science doing the research with us. As we're involving the people, they will take part of the research, they'll be more involved. And this community will build an ecological center, meaning with 2 people full-time on staff, meaning that everybody who moved to Bonita Bay Community Association will have to go through a training to learn about water quality, the watershed, and everything else, so they better understand what to do and what not to do. I also have some work in pending with Cape Coral Canal, where we're tracking pollution, as well as Estero Village, where we're looking at Pelican Sound as our guinea pig here to start to looking at surface and groundwater interaction, looking at bacteria loading into the Estero River, and using steel sucralose as a way to trace nutrients from wastewater. And that will be it. I think I'm just right with my 45 minutes, and I'll take any questions.
So yeah, you got the timing perfect there. So we can open it up to questions. If anyone has one, please unmute yourself and go ahead and ask.
Don't be shy, I don't bite.
Sirs, this is Andy Tilton. On the aerators that you were showing in that one particular pond, that they weren't covering all of the pond, maybe not even a significant portion of the pond. Were those some that were just placed there, or did somebody design those? I know.
No, these were Vertex Aerators, so Vertex Technologies, and they were actually serviced not too long ago. So I want to make sure that they were working at least 2 months before to the study, and they were running for about 4 years.
Okay, because we put aerators in a lot of ponds, and I know that the shape of the pond, the depth, and all play into what
Absolutely.
The recommendation is for placement as well as the quantity of them.
Yeah, so this is 1 acre pond, and 2 is actually more than what's recommended rate, which is normally 1. But they have a lot of issues with water quality, and they're pretty deep. And so we have about 2 to 3 meters deep where those aerators are. So it makes sense because the water used to be stratified before they had those. But like I said, this is just so middle of the summer when the water is very stratified, and we wanted to see how well they aerate the water. But this is just aeration. There is also diffusion that enter into play. And we're looking now at using an ADV, several ADVs to see the flow. That's how they actually generate flow, because that's not only, here we're just measuring temperature and DO, and we're gonna reduce that again once the water will be stratified again, so probably in May. And at the same time, we're also gonna use ADV, so flow velocity meters, to assess away from where there is a bubble, because there is a problem with the bubbles and the ADV, but try to assess on the whole scale how the water is being circulated using those aerators. And this is a bit more complicated here because this is actually a non-disclosure agreement, but we're looking at a contraption that they put on top of those aerators to enhance aeration. So this is exactly what we are. The purpose is really to see how well that booster in aeration help the aeration of the pond. So we have 3 ponds. We have pond with no aeration, pond with aeration alone, and pond with booster and aeration altogether. So that's really what the study is about.
Okay, I'd be real interested in that, like I say, we have recommended aeration in many places, and some places have actually spent the money to install it. And
absolutely,
if
yeah,
we can
I'll
do a
share those
better
data.
job.
Just the one without the booster, because the booster is proprietary, and if it doesn't work, I cannot show you the data. But if it does work, I'm sure the company will be very happy to share the data.
I understand both of those. And a second question, if we don't have others, is all of this work has primarily been done on how do we fix what has already been done. What recommendations might you have, or you may want to think about it for a while, on the design of new ponds? Because from a volumetric standpoint and an attenuation standpoint, there's very little way to get around having ponds as part of the landscape going forward under our current regulatory requirements.
Yeah, and that's a big conundrum. You hit the nail on the head here. So for the general audience, the conundrum is, well, first is that most people want to actually have a pond. They don't want to have a dry pond. Now, if you have a dry pond, you also have less flood buffering capacity because you have less volume, right? If there is a flood. So for regulatory purpose, if you're going the route with a dry pond, ponds or swells or wetlands, because you'll basically end up with a wetlands if you let it grow, which would be ideal. You need more surface area, obviously. So that's a conundrum. So in terms of design, well, first I would definitely avoid the super the maze-like pond, because they are a nightmare to manage. I'm sure you actually experience those ponds that are very, very. We have to exit the presentation here to be able to move through it easily. But those ponds are very, very convoluted, are definitely a no-no for me in terms of water quality, at least, or at least they should change the way they manage their lawns and the planting, especially. In terms of water depth, I know that it's controversial. So Harvey Harper wants to actually have them dug deeper, and for me, I would like to see them less deep. And probably with more littoral zone, but again, that's reducing the flooding capacity. But when I talk to people who talk about flood, and I don't know much about flood because it's not my aisle, apparently the pond do not much in terms of flood mitigation. So it's mostly the drainage that's more important than the pond itself. So I don't know, this is not my aisle here, so I won't venture there. But apparently that's one of the issues. But in terms of design, more shelf, more like a good shelf, and then eventually plants, growing into that shelf, and algae eventually growing onto the plants, so that they're attached to limit nutrients entering the open water. Again, the open water has never been a good way to sequester nutrients. You just grow algae, and those algae are not attached, and they will be exported with the overflow. So you want anything that's attached, whether it's a periphyton base or a mat, algae mat, or a plant that's rooted, or that would not go through the overflow, would be the best.
Thank you very much.
Thanks, Andy.
I have a question.
We should get together often, Andy. We got a lot of stuff. We're going to talk.
Go ahead. Someone had a question? I thought I heard someone with a question.
Can you hear me?
Yes, we can.
When I see the pictures of the ponds, it seems like there are littoral plants 100% of the area around the pond, but you're saying only 35%?
35%. So if I base my number, okay, we don't have enough data to support that 35% on artificial pond, but in natural ponds, natural lakes and ponds, Dr. Canfield, so UF, came up with a number of 35% of plants covering the bottom of the pond, regardless if it's a littoral zone or in the center of the pond that's shallow, is the ideal number, because you're hitting a tipping point when the plants start to have actually direct benefit on the water quality. So if you're below 35% or 30%, you are below that tipping point, meaning the water will still be impacted by nutrient. When you get above that threshold of 30-35%, you actually have the plants that will have all the benefits kicking in. Benefits being they sequester nutrient. They also prevent what we call resuspension. So the shallow water in the littoral zone, when it's windy, will be easily resuspended. So when you have plants that are rooted, especially with roots, anchor into the bottom that will prevent resuspension. Now, resuspension is bad because if you're because it will make the water more turbid, and that water that has turbidity, especially if you have a lot of muck in the littoral zone, you will kick in nutrients in the water. So you will increase what we call internal loading. The nutrient in the sediment will move faster into the water column because they've been suspended by wave action that's wind driven. So when you have about 30-35%, you're preventing that from happening. And you're starting to actually have a much better water quality. Of course, if you go above the 35%, it's even better. For Lake Trafford, which is a natural lake in Immokalee, we're trying to restore the lake to the 30-35% of submerged aquatic vegetation and emergent aquatic vegetation rooted into the lake to hope to actually see a positive impact on water quality. Right now, we're far away from this target.
I'm also concerned about the wastewater treatment facilities that can put out as much phosphorus as they want. Is that true?
Yeah, that's troubling to me too. Apparently the Lee and Collier at least, and apparently it's also valid for Hillsborough County because I had somebody on the phone the other day. They wanted me to be on the panel to because they're actually thinking using reclaimed water to maintain minimum flow rate in the Hillsborough River. And I had concern about doing this. I mean, sure, we need the fresh water, but we don't need the nutrient that tag along with it. So yeah, the problem with phosphorus in wastewater treatment plant is that it's very difficult to remove phosphorus from the influent, from the raw sewage. The only way you can remove it is either through a process called flocculation, where you're using some chemicals to make the sludge clump together, and as it clumps, also attract phosphorus with it, and then you're removing it. And the other way would be uptake, so using plants, algae that you would grow in pollution lagoon to treat that phosphorus, for example. That's very convoluted, takes a lot of effort. For the nitrogen, it's a little bit different because nitrogen, we can what we call denitrify it. So denitrification is a process to change nitrate into nitrogen gas, which will get into the atmosphere. So nitrogen is an easy target, if I want to say. Phosphorus is a much more difficult. So they're very lucky in some ways that they don't have a threshold for phosphorus. And pretty much the effluents can have as much phosphorus. They won't get penalized for it, but the nitrogen is definitely something that they look for in terms of reduction. Remember that nitrogen doesn't have much impact inland. It does in some ways, but not as much impact inland that it has on the marine system. Generally, marine systems are more prone to nitrogen eutrophication, so growing algae, compared to phosphorus eutrophication. Although it's not all the time the case. Like I work in Florida Bay, and depending on where you are on the bay, you're phosphorus limited or nitrogen limited. But most of the time, it's nitrogen limited. So in terms of protecting the bay, it's okay to have a mandate for nitrogen in the reclaimed water. But in terms of growing plants and algae inland, not having one for phosphorus is troubling to me.
Thank you.
One of the things that I'd suggest is if your irrigation water is from one of the local wastewater plants, find out from that entity how much because they have to measure how much is in it. Because for instance, the Pine Ridge plant that Lee County Utilities operates usually runs around 7 parts per million. But the Fiesta Village usually runs less than 1. So there's not all reclaimed water is equal. So you really need to find out what is in the water you're using.
Yeah, it does vary greatly. You're right about that. And it also does vary. So that's something we're going to do with Bonita Bay Community Association, because they're receiving, they have SRS ponds, 2 of them. And so that means they are receiving directly reclaimed water from the Bonita Spring wastewater treatment plant. And that gets fueled directly either through irrigation or through a succession of ponds, which are terrible water quality. I mean, Andy, you could not believe this, the trophic status index, it goes beyond 100. They have 120, 130 for the TSI, trophic status index. So very bad water quality. But what we're trying to see is that how does the water change from the reclaimed water from the plant to the sprinkler, and it does change. It's amazing how well it changes too. So it's not only about the reclaimed water exceeding the plant, it's also the reclaimed water at the faucet, at the sprinkler. It changes water quality as it travels through the pipes. And we had several presentations presented at the Florida Lake Management Society symposia regarding this, and that's what they never got published. So that's what got me into the project. So I'm working with an engineer, Ashley Thompson, whose emphasis is on the wastewater treatment plant. So she's really excited to start that research.
And I have heard several people say that there is a change between the plant and the wastewater treatment plant and the sprinkler head. And so, yes, that's an additional item to check, but start out with what's coming from the plant, and that'll give you an idea of what what range you're looking for when you're going to the sprinkler head.
Absolutely.
Well, hey, that's all really interesting, and we hit the top of our hour here. But Serge, thank you so much. It was a great presentation. Lots to think about. You know, it seems like there's a lot that we do that sounds good, and then we do it, and maybe it's not so good. So we all have a lot to think about as far as taking care of our ponds. We wanted to let you know that we are having our Lee County Pond Contest coming up soon. So we want to ask you to check out our website and make sure you keep your eyes open for that contest. And there'll be 2 parts to it. I'm going to go back to that. You know, if you have a great pond that looks beautiful, we're going to be doing a contest for that. And if you have a pond that maybe needs some help, we'll be looking at possibly giving out some mini makeovers. So watch for that on our website. You can check out our website to view this webinar again if you'd like to, because there was a lot of information in there, and you might want to share it with your friends. So send them to our website. They'll be able to find past wet plan pondside talks there, and also a lot of other resources. And again, we want to thank you, Dr. Thomas, for a great presentation. And with
My
that,
pleasure. The idea is hopefully people will be able to watch it and at their own leisure and circulate it like my TED Talk. It's a good way to circulate the information.
yeah, that would be great. So thank you everyone for joining us, and we appreciate you taking the time. And I'm gonna stop recording now and we'll end our webinar.
Thanks, Karen. Thanks, Serge. Thanks, everybody.